Hello everyone. Another day, another stream. Today we'll start with the day problem on LeetCode. Today's problem will be remove zero-sum consecutive nodes from linked list. So that would be the starting point. After that, we'll go to neatcode.io and we'll continue with our 2 pointers. So we have remaining 2 problems. A container with most water and trapping rainwater. So these are the 2 problems, and after we will switch to stacks, and I guess that's my favorite problem. Valid parentheses. So we'll start solving stack problems. Okay, so there is some work to be done today. But let's first try to finish with this problem. And it's a bit interesting. I see the acceptance rate being 47.9%. And the suggestion here, it's a little bit weird. I'm not sure if I want to go this direction. But first, let's read and try to understand what do they want from us. Okay, so let me check if everything is up and running. Is this stream up? I think it should be. I mean, it should be, but it looks like it's not yet running. Yeah, but it's up for a minute. Probably it's a short delay. Okay. 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 Cool. So everything seems to be in norm. Yeah. So the problem itself, given the head of a linked list, we repeatedly delete consecutive sequences of nodes that sum to 0 until there are no such sequences. So it's an interesting problem. After doing so, return the head of the final linked list. You may return any such answer. Note that the examples below, all sequences are serialization of list node objects. So we have a couple of examples, like this one, and then this one, and then the third one. So let's try to brainstorm a bit on our whiteboard. So I'll need to take the screenshot. I'll be copying all these 3 examples. And yeah, probably I started thinking something here. Maybe I can zoom it a bit. Yeah, should be good enough. Okay, so first example, this one. What do we have? We have the first item, the head at 1, and then we have pointed to 2. Then we have a cool sequence of 3 and -3, which kind of will need to remove those 2. And then we have a 1 again. So I was thinking, yeah, we'll need to keep the head for sure. But the trouble is the head will be mutable. So maybe we'll need to do a clone of the head of the list. And that would clone the list from scratch. Yeah. So the simplest way will be traversing our list, and we'll keep like 2 pointers, previous and current. So we can check if the sum of the previous and current will be 0. Then actually maybe we'll need like not 2 pointers but 3 pointers, because we will not even 3 but even 4 pointers. Because imagine this situation. I've got here, so I've got to 1, and then I got to 2. Then I'll need to keep the link and remove this 2 minus 3's, like 3 and the minus 3 1. But in order to do that in a linked list, we'll need to keep this pointer, because this pointer, the next of this pointer, will point to the last item 1. So in order to achieve this situation, we kind of need to store a couple of let's say pointers. So it would be something like this. Yeah, now I understand why this is such a low acceptance rate, because it's not easy. For sure, it's not easy. So let's imagine we start first traversing. So we'll have like the head pointer. So let me call it pointer P, which will be at 1. But actually, yeah, I don't know how to initialize them. That's the trouble. Maybe that's even a good idea to transform this into a list, do the cleanup, and then transform it back to another list. Maybe that's actually a viable approach to solve it, an easy way. I was thinking to kind of mutate and play around with this linked list and try somehow to manipulate it in such a manner that I can get this pointer and link it directly with this one by removing these 2 items. But it's not easy. Let me try to see what can we do here. What can we do? Okay, so let's imagine we have 1, 2, 3, and minus 3 and 1. So in linked list, we'll need to traverse it one by one, so there is no other option. So let's imagine we are at this one. It's a 1. We are at head. We cannot do much here. So we'll need to move on to the next one. So let's call it previous, and this will be current. So we have like these 2 pointers for now. Previous and current. In this case, their sum, it's not 0, so it's not important for us. We can easily move on. So previous will be this one. So this will be previous, and this will be current as well. Sum is not 0. Then we have this one previous and this one current, and we have bingo. So we found our 0 sum. But in order to remove these 2, we kind of need to store somewhere this one, and I'm not sure how to call it, like PP. And in order to do this transition, we'll need to know the next of this one, which will be like okay, previous, and this will be like a current next or something like this. So I'll need like to have 4 pointers, and this is for the case where we'll not need to delete from the head. But we have another case. Yeah, the other case for us would be, let's imagine we start with 1 and minus 1 right away. And then we have like 2, 3, and 4. So the head will be nullified with this current. So these 2 will disappear. And the new head will be this one. So yeah, there are many combination of things which manipulating the list would be troublesome. So probably we should go with a vector. I feel like oh, Oh, hello, Unwarekare. Hi, hi. How are you doing? How's life? Long time no see. I got lazy lately. I start playing more, so start playing like a last epoch. Okay, so this approach, it's very. I think I can manage to code it half night or 2 3 hours, and would be quite efficient to some extent. But it's a nightmare to code it. Oh, good. Yeah, awesome. Did you solve the today's problem? This one, which I'm trying now. It's quite interesting. I mean, they suggest to go with an array. At first, I kind of was feeling like, nah. I will think something smarter, but nothing comes to my mind. So I guess the easiest way, I'll traverse the list one time, form this vector. Maybe even I don't need to form it as a vector. I will just do it at runtime using a stack. Oh yeah, that's even a good idea. Okay, so yeah, this one it's pretty interesting. So I'll be traversing the list and use a stack, and we'll keep the values in a stack. So imagine if there is nothing in the stack, we'll put 1. Then -1 comes. I can check what was the last item in the stack, and it's not 1. It's, I guess in this case it's 1 and -1, and we will remove this one. So we'll pop the last one. So I'll put 1 here, I'll put -1, then I'll pop both of them because they are 0, and then I'll move on with 2. I'll put 3, and then I'll put 4. And by the end of traversing this linked list, I'll fill my vector. I'll fill my vector in, which is pretty cool and make me think, why not at the same time, in the same for loop, to use this stack approach and at the same time kind of create a linked list. But yeah, that will be a bit more problematic, I think. So yeah, let me keep first using this stack, generating the end result, and then transforming this vector into a linked list and returning it. So yeah, I feel like that would be the most optimal way to solve it. So yeah, we traverse the linked list, use a stack to get the last item, and see if the last item it's where last item plus current item gives the sum of 0. Then in this case we will pop them out, and if not, we'll keep them in the stack. And by the end of traversing the linked list, in the stack will remain all the good values. And after, I will just transform this vector into a linked list. So that's the plan. Okay, so let's start coding, I guess. Yeah, I've prepared here. Yeah, I'll need to add a test for a scenario, but it is a bit annoying. But I guess we'll need to. So I'll need to create a head, and my head will be an option. So this needs to be a sum. Then it will be a box new of list node. And inside I'll have like 1, or val would be 1. Yeah, I'm trying to, I guess let me try to go with this scenario. So okay, so let me comment this. And we'll have next, which will be as well as sum. Inside a box, new, a list node. Val would be 2. And next will be sum. Box new. List node. In this case, it will be like val -3. Sum. Box new. List node. Vol being like 3. And next sum. Box new. List node. Yeah, binary trees and linked list, it's very annoying to create like test data for them. So it will be 1, and next will be finally none, because that would be the last one. So I do have my my head. Now I'll need an expected head, wherever. So it's a bit less, but it will be 1, 2, and here 1, and next side will be none. If I understood correctly. Okay, so yeah, that would be the case. So yeah, let's run our assertion. Assert equal. Yeah, I wonder how Rust asserts linked list heads, because I'm pretty sure it doesn't look recursively. So for this case, probably we'll need to add like a small helper function, which we'll be using as well inside our solution. But something like a fan list back head, and this will be an option of box of list node, and return a result would be a vec of I assume it's I32. Yeah, I need to implement equal. So okay, so they do have like equal, derive equal. So maybe I don't need this. Maybe I don't need this actually. I don't know. Maybe I don't need this. So anyway, so we have our solution, and then we have removed 0 from head. This needs to be equal with the expected head. So we have our test case. This part is done. Now I can check our theory. I just can return the head, and this should fail. If this doesn't fail, then it doesn't go recursively, and we will need to, yeah, looks like it goes recursively, so that's very good thing. Look here, so expected is not equal with the left, is not equal to right, so that's a very nice job done by Rust guys. Yeah, so I don't need a helper function for this case. Okay, yeah, what else? I guess now next spot will be to traverse this. So yeah, we'll need immutable stack, which will be a vec. Yeah, it will be a vec of I32s, where we'll keep our like solution. Then we'll need to traverse our list. So let's assume we have while let's node, I guess, and we do head. Actually, I don't like to go this way. Maybe I'll do something like let mutable current, and this will be a reference of head. And then I'll do current. Yeah, that would be a more pleasant way to do things. So yeah, if we have something, then we'll do like a value would be current dot borrow dot val. I think here semicolon why current, no, not current, it's node. Okay, so node as ref, I guess. Okay, so it doesn't understand this part. Yeah, every time I have some troubles with traversing the linked lists with the compiler, because I think it should be as ref, and then we'll do borrow, or maybe we don't need to do borrow anymore. Well, okay, so we've got our value. That's good. So that's important for us. Somehow we managed to get our value. Now it's the logic with the stack. So here we'll do while but actually, do we need to do it? I think this, we have a simple check. If stack is empty, then we do stack push value. So that's the simplest case. Else, we will pop. Or actually, we don't need to pop. We may pick inside. So we may try to pick first. So let previous. It will be like stack peak. Wait, I'm pretty sure there should be like. Okay, whatever. Let's just pop. And then I'll add both of them. So if there will be troubles. So I need to check the previous. So this would be unwrap kind of. It's a safe way to do unwrap here. Maybe I can be a little bit more sure and write it in this form. Let's sum previous. Will be like stack.pop. So in this case, I will not need to validate it. So I've got the previous value and I've got the current value. Yeah, maybe I should call this current. Current. And this, let me call it current node. And this will be current val. This will be like previous val. To be more accurate with the results. Okay, so we do have the previous value. Now let's check if it's equal to 0, if current val minus previous val, where it's plus. What's the constraint? Zero sum consecutive nodes. It's a sum, so it should be plus. If this sum is equal 0, then we don't need to do anything. If it's not equal to 0, then we'll need to insert in the stack back previous val, stack push previous val, and we'll need to push current val. Okay, so this would be the logic to traverse and eliminate everything which is not our stack. And yeah, we kind of need to move on with the while loop. So we need to make current node to be like node as ref again, and next, I think. Will this work? Okay, so expected as ref. Okay, so that would be the traversal. So I assume here, let me do a debugging trick. I just want to see what's in the stack, but my stack should contain like 1 to 1. So that's the things I'm expecting. So indeed, we have like my stack, it's 1 to 1. So next stage for my problem is I need to transform this result, this stack, into a linked list. And yeah. I guess we will need like a start. Head, I don't know. We'll need something similar. Okay, so I guess we'll need a start of the head. And this will be like some box. I'm thinking, I solved one problem with this and I had like huge troubles making it work. And I try to remember how did I do it. Exactly this thing to create. To create a linked list from a vector, which seems trivial. I mean, in other languages like let's say PHP, JavaScript, maybe even C++, it's easy to do. But Rust, it's not trivial. I mean, literally, that's a very, very not trivial task. Okay, so we will need a head, which will return. Then we'll need a current to traverse. Because current will change, or tail. Let's call it tail. But this will need to be borrowed mutably. Okay. Okay, so what should I do? How should I do it? Maybe using a fold function. Yeah, maybe a fold will indeed work. How about this? But I need to skip the first one. So yeah, I'll need to create a head first. So let's do let first would be like stack of 0. Hopefully we'll have a non-empty linked list, otherwise it's I'll need to. Okay, so if stack is empty, let's return in this case none, as we don't have anything. So that would be a shield for us to not get into troubles if we have an empty result. Else, we'll start with the first item. And then let me create this new this node, and here I'll have the val part being first. And for now, next will be null. Not null, but none. So that would be our head. And I'll be creating mutable tail, which will be a reference of head. I really hope this works. Now we will go with numbers, so like vals or val in. We'll have stack. Here we'll need to skip one because we already used one, and maybe I even can consume it, so I'll use into iterator. So here I will do like let node be sum box new list node, and I guess I'll use here val. I think it's like this, new and val. So I have my node. Now I'll need to link the previous tail.next, borrow mutable, mutable option box list. Yeah, that's weird, but so prep.next. Wait a second. So tail would be option of box list node. What I want to do, it's like set inside this next this node value. So that's my goal. Question is how to do it. Yeah, question is how can we achieve that? So let's have tail.next doesn't work. So we need like us ref maybe. Borrow. It's still option. I need kind of to unwrap it. Okay, so I'll do, I guess, something like if let's prev would be prev box. Let's call it like this. Would be tail. Okay, so now we have this part. So we have prev box as ref dot next being this node can assign data in a reference. That's true. As mute. Cannot borrow prev box is mutable. It's behind the reference. Yeah, that's tricky. I mean, yeah, time I guess to use the help of Copilot, because I'll spend like another half night. Uh, I'm very close to the idea. Okay, so that would be. So I'll need to do like tail as ref dot borrow mutable dot next. So that and this doesn't work also. Uh, yeah, let me see what does it suggest. Okay, so I have new node would be this. Okay, tail as next new node, tail as ref borrow next. So that's my idea, but this doesn't work. So it looks like Copilot doesn't know as well. Yeah, that's tricky. No field next and type mutable option. Yeah, for sure it's not, because I'll need this like if let's I guess tail would be tail. Now there will be. But maybe that's a bad idea to tail box. Okay, so here we'll have cannot assign data in a shared reference. But how can I assign it? I mean, yeah. Hi, I'm a beginner at Java and I'm having problems writing a driver and help a class in Java. Can you help? I use Notepad, by the way. I'm not a Java developer, unfortunately. So conceptually, maybe I can help, but with syntaxes and stuff, it may be problematic. But I can give you some ideas if you can share what's your troubles. That would be a possibility for sure. Okay, how can I create a linked list from a vector? I mean, that's should be easy. I mean, what's fn? Okay, so linked list from vec, and I'll do vec. So what does it do? It does this. Okay, so at first it's this, then it's head. Okay, type notation needed for option T. You use Notepad. I don't know about Notepad. I suggest you to use VS Code at least. It's way better. I mean, so yeah, with this syntaxes, let me see, because it's similar with what I want to do. Cargo test unknown field box next. Yeah, option none. Yeah, because here we'll need like as a mute. Wait a second, maybe we get somewhere. So that would be like option of box list node. Oh my god. So we were very close. But the trick was to start the head first with wait a second, will this work? At first, head is none. And tail will be head. And then if let some tail box, but it's none. This is none. This will not work. I mean, the idea it's right, but implementation is wrong. Okay, so I guess what did we miss here? We have the head part, which we start this, and then we have this node part, which is here, and here we don't need this. Okay, so what's the as mute? Okay, so it's not borrow, but as mute. Tail box, and I think wait. Tail. I don't get it. What's the difference between this and this? I mean, literally, it's the same code. So instead of vac would be like skip one. Okay, into iterator. Cannot borrow tail box as mutable as behind a shared reference. Okay, but this works. Yeah, that's interesting. So how about this? I guess in this case, let me remove this. Command this part. And let's run it. Yeah, it's none because this is too smart. Because I'll need to write something similar here. Okay, so all that logic. Return none. First would be this. None, and then this. So I guess that would be the way to go. So val1 next, some list node val1 is wait. Yeah, I'll need to skip one here. I'll need to skip into iter. Skip one. Yeah, and now we need guys to figure out what the freaking difference between that code and this code. What's the difference? Okay, so we have let me comment this as well. So if stack is empty, we return none. Now we have this head, but we'll not have it anymore. And now we do the following. So vector is empty. Yeah, that logic it's understood. We have a mutable head. Oh, here we did not create it mutable. So maybe that's the case. Maybe that's the problem. Else we do this. Then we do the vol part. Then we have the new node, which does exactly the same. And here we have let some tail box. So then tailbox as mutable next will be new node. What? So what's the difference between? And we're returning head. So this if else. I do not see the difference. Oh. Whoa. So, so if I extract this into a separate function, it does work. But it doesn't work when I, yeah, that's very weird. So if I keep it in a separate function, this works just fine. But if I have it here, so my assumption is that there is somewhere trouble with this head, maybe. I give up. I don't understand. I don't understand how this doesn't work. Why this doesn't work. It's literally the same logic. Yeah, Rust, it's freaking weird. Run. Cargo test. Yeah, let's read. What does it want? So tailbox is a reference. So the data it refers cannot be borrowed as mutable. Cannot borrow tailbox next as mutable as behind a reference. What the freaking... Here you can, but there you cannot. What's the point? What's the difference? Yeah, let me do it like stack or array, whatever. So literally same logic. I call it here. I remove this part, so I'll do like even I think I can even what's the name, linked list from back. So this works just fine. Yeah, test case is correct, everything good, no complaints. But if I write it down, the same code, literally, here, let me transform it. So I'll have a stack. I'll copy this. I'll copy here. I'll just paste it here. So I don't even need this part. I run it. Now it worked. Now it worked. So there was a mistake somewhere. I don't know where, though. Yeah, Rust, it's weird. Oh my god. Okay, so cargo Clippy, let's see if we can improve something, anything. Nothing to improve here. So we do have our algorithm. I think we can tell thank you for Copilot that it helped us with the syntax. Because the algorithm I've made it, but I have troubles with how to exactly traverse the linked list. So Copilot was very helpful. So yeah, let's try now to run this on lead code and see if it does work or not. It should, and is pretty efficient in a way, the algorithm. It's quite a lot of code there, but should be fine. Okay, 1 millisecond. So yeah, let's try to submit now. Yeah, so it looks like the algorithm doesn't work as expected. Somehow for this scenario we have some troubles. So the question is why? Yeah, let's try to simulate it. And for me to not waste like half a day, I guess this part. Yeah, let me check what's going on here. So first step, it's empty. So stack is empty, we'll push the current value. Second step, we go next, blah, blah, blah. So it will be -3. It's not empty anymore because we have like 5. Here we'll pop 5. So previous val will be 5. Current val plus previous val. So 5 minus 3, it's not equal 0. Then we'll push both of them. And we move on. So it's -4. Wait, how did we get to output? Wait a second, that's maybe I didn't get the problem, because we have we may have like multiple numbers having the same sum. Oh, I was thinking of using only pairs. Oh, so yeah, this will not work. Yeah, this problem is way more complex than I thought. But anyway, we did like the huge and most annoying part. Yeah, the trick here is that I need to kind of sum -3 and -4. And then I'll see here that this will be -7. And here it will be 7. And I'll need to remove this too. So, I thought it's only valid for pairs, but it's not. So this stack approach wait a second, but maybe we can. Okay, I guess we will transform our problem a bit. So I just want to get out from this linked list universe. So because this is annoying as hell. So and we are out. We can create our linked list, which is very nice and everything. We can traverse the linked list, so we're good. So then our algorithm will need to change. And let's think a bit. How can we improve it? So let's assume we are not in the linked list universe, but we are in this -1, 3, -3, I don't know, 2. So in this case, this will nullify, and will remain with 2 only. So, but if we go with this example, which is a bit more tricky, yeah, today's problem is no joke. I had plans to finish and start stacks, but I feel like that would be quite unlikely. So we have like here, wait, I can zoom it out a bit. So we have like 5, -3, -4, 1, 6, -2, and -5. So if we go, because this in itself, it's a complex problem, so it's not so straightforward. Okay. Yeah, let's assume we go in a linear way. And we may have like sort of a prefix sum, maybe. Try some prefix sum strategies. So what we know is that it is a sequence. So this should be a sequence. So maybe we can think of going some recursive approach, where I don't know. But our sequence may have like a pair number of elements, so an even number. So it could be like 2, either 4 or 6 elements. So assuming we start with 5, we can check next item of 5, which will be -3. So obviously this 2 is not 0, so it doesn't start a sequence yet. So in this case, we may have 2 options. Like 5, it's not part of any sequence. Or 5, it's part of a sequence. So 5 could be part of nothing. Or it could be part of some sequence which will be nullified later on. So we have a branch here. So either we have like 5 and 3 already. Or just 5. Because -3 would be part of the sequence. So probably I need to mark them not in a sequence. Not sequence, but here in a sequence. In a sequence. No, I feel like it should be something easier. Because the way to go, I guess, to go with some sort of dynamic programming approach. But in this case, this problem would be hard, at least hard. So yeah, let's check again. So convert the linked list into an array. Hash table linked list. The other option, what would be another option for us? Okay, so let's assume we have some sort of sum. So we increment we add the items to sum, so it would be 5. Then it will be like 2, because we reduce -3. Then it will be like -3. Then it will be like -2, and then it will be like 4. Doesn't give anything. Okay, yeah, that's a pretty interesting problem though. Maybe I can go oh. So we have a start of a community here. So people helping each other for my channel. So that's really, really good. I like that. So good. So yeah, let's continue the brainstorming part. Continue the brainstorming part. Maybe we can do a lookup. So with this approach of checking if is part or it's not part of a sequence. So how can we do that? How can we check? So for example, how can I tell that 5? Yeah, let me read again the definition of the problem. Consecutive sequences of nodes that sum to 0 until there are no such sequences. Yeah, and this case kind of destroyed me. Yeah, let me use this case, because here we have this -7 and 7 part. Theory, and we may have like sequences of 3 items, 4 items, and the entire vector maybe. So yeah, I'm thinking maybe with complements we can go in some direction. Yeah, that's a converted array. Okay, so while we can find a non-empty subarray with sum 0, erase it. While you can find a non-empty subarray with sum 0, erase it. Okay, so kind of we go this way. To do all possible combinations, and if it's 0, then we remove the array from the main one. But how will we find the biggest then? Because look, this needs to be consecutive, so it's not that many combination in this case. So maybe here with the 2 pointers we can play around. Yeah, let's think a bit. So we are here. Let's say 5. And wait a second. So what do I need to do? Like compare 5 with everything. Okay, why did I get into this problem? Okay, so we need to remove them. Guys, maybe you have some ideas? How can I erase subarrays? So I know here that this is a subarray which is 0, but I mean to create all possibilities of sequences of subarrays and then find the 0 ones. This will not end in any time. Why Rust? Yeah, I kind of find a pleasant vibe for Rust. So I try to learn it. Also, it's a memory managed language, so overall I feel like it has a very nice potential. And also I'm a Node developer, and in order to make Node faster, I can build like native extensions using Rust. And trying to improve my coding skills overall, but for this problem I would not solve it in JavaScript faster. I mean, we spent like some good chunk of time playing with the linked list part, but the linked list, it's not the trickiest thing here. The trickiest thing is how to remove those. How did I do that? Not sure how I did this. I'm not sure how to put it back. Okay, whatever. Let's use a new canvas. So yeah, let me go again. We have this, and we need to let's assume I will need to come up with a solution. So maybe I should look into some dynamic programming approach. So dynamic programming approach. Let me write down here, and I'll need to play around a bit. Where, let's say, brute forcing approach using dynamic programming, and maybe we will get somewhere. But the trick is though, so yeah, let's start with 5. What's 5 about? Yeah, I'll write here the ones which maybe start of a sequence, and here here non-start of a sequence, and here just the sequence. So let's assume we put at first 5 here, and then how can we check if it's part or not part? Oh yeah, thank you. I want to create like a pleasant vibe and myself to improve my coding skills. But you stumble upon such problems, so for God's sake, I do not wish anyone to get into this during an interview, because this is a type of a problem where either you know the trick, or you will spend like hours to solve it. Because I don't really want to do all possible combinations of sequences. Let's say if you go with the brute forcing approach. So what would be a possibility? So I'll need to create all possibilities with 5, which will be 5 till minus 5. I'll do a sum of this and see it's not equal to 0, then that's good. Then I'll move on to 5 minus 2 till minus 2, then 5 till 6, then 5 till 1, then 5 till minus 4, and then 5 till minus 3. So we are done with 5 in this case. So as you can see here, we did like 1, 2, 3, 4, 5, 6, 6 sums were so. So we'll need to do like for each number, we'll need to multiply this sum. It will be like another n, so it gets to n cube, I think. The time complexity, because after we did with the 5, if we didn't find any like subarrays, next thing will go to minus 3. So minus 3 till minus 5, and then it will be like minus 3 till minus 2, and then minus 3 till 6, and here actually it will be a 0, and we will be removing those. So maybe I should code this approach. I'm thinking maybe I should code it like this. But yeah, in Rust it's a nightmare, because I cannot mutate the same array I'm playing, so I'll need to do clones and copies. So that's not easy. Is there another way? How can I do it faster? I do not see it though. No, I do not see it. I mean, that's yeah, this is some sort of two pointers approach, or sliding window approach, I guess. Another name for this would be. It's like we have like a left pointer and a right pointer, and we'll go the right till pretty much +1. It'll be right. It'll be left +1. The next. If we didn't find anything, I guess we'll do left +1 and start again from right backwards, start again, right backwards. So that's the simplest possibility. Yeah, let me check the constraints. Maybe the constraints are kind of, wait, constraints. Yeah, actually it's acceptable, because we'll have 1,000 nodes, so it's, even if it's n cube, it will be 1 billion operations. So more or less it's not so bad. Okay, yeah, let's start kind of coding this. Oh my god, that's yeah, let me move this one into function, extracting the function, vector to list, just array, call it, to have it a bit in a better form. So that's the case, and this would be like self back to the list. Okay. Now let's get a vector part. So this will be the traversal. Maybe I can do it another function. So that's not needed anymore. This logic is not needed. So I'll just have a stack that push current val. So this logic will get us from a linked list to a vector. Linked to a vector. So I divided everything into small functions to manipulate it easier, I guess. Solution, linked list. So yeah, let's rename it, because now it will have a result. It'll have a bit different naming. Add some spaces. So yeah, we have this vector to linked list, or array to linked list, vector to list. Then we have back linked list to vector. And now we'll need this cleanup function. Fn pub clean sequence. Pub fn clean up, I guess. Zero sum. Clean up zero sum. So I'll be passing a vector. Vec. This will be a back reference of back I32. And I want back another vector. Y32. And here it will be like result. And here I'll do like solution, clean up, result. So yeah, that would be the algorithm. But now we'll need to code this this cleanup zero sum part. And for this, let me add like another test, scenario test, clean up zero sum. We'll be adding a couple of scenarios. And most important, it's this, I guess, and the previous one. And here we'll have like 1, 2, 1. So, and we'll need this big one for this to work as well. So we have like a problem inside a problem. So tons of work ahead. Yeah, I had plans to do other problems, but unlikely I'll manage today. So let's, I guess, let's get this one done. And once it's done, then we'll be able to move on to other problems. But okay, so we have scenarios, not scenarios, but it's solution. clean up zero sum, and this needs to be a reference. Okay, so we set up our test cases. Definitely they will not work. And now we'll need to code it. So let me move this up. I'll move this one here. And I'll move this one here. Probably this too would be nice to have them inside here somewhere. But they are fine in solution as well for now. Okay. Okay, so let's start coding our brute force. So for this, I'll have like a couple of pointers. It will be left and right. Oh, so actually it's inside our theme of 2 pointers. So the right part would be back of len. Yeah, I don't really like it to call it back. Or okay, maybe let it be -1. Yeah, back len -1. So if we do this, what would be the algorithm though? What would be the algorithm? So we start with left and right. Okay, let me use a new canvas. So let's start first, I guess, with the first example. 1, 2, -3, minus. So it will be like 1, 2, -3, 3, and 1. So we have this vector. So we have our pointers, the left pointer, the right pointer. We can do fastly a sum of this, and we'll see it's not 0. So at first we do this, and it's not 0. It will be something different. It will be not equal to 0. In this case, if it's not 0, then we will decrement r. So r will be here. So we'll have a new state. We'll have left, and the right will be at this stage. This one is not 0 again. We go next with another layer. So L and then R will be here. It's not, and this one is 0 actually. Wait a second. Do they allow 3, 1 as a solution? Oh, they do allow 3, 1 as a solution. So yeah, that's mind-boggling. Because this one is 0. So actually we found it and we can remove it. But this needs to be called recursively, I guess. So this one, it is 0. So and then this means we will remove, starting from our vector, starting position left till position right, and we will be remaining with the 3, 1. And when this stops, when our algorithm will stop, that's the question. Because is 3, 1 equals 0? Are we sure that it's not 0 anymore? Maybe we should go recursively. That's interesting. At least it has like a a feeling that it will work, and maybe it's not as bad. But still, this one, it's n square. So it's still pretty bad though. Okay, I guess let's try to code it and see where we'll get. So we have left and right. So we do while left it's smaller than right. We will do yeah, we kind of will need to call this recursively. But if you call it recursively, then we'll need to make sure that we do not cycle indefinitely. Oh my god, why did I get today into this problem? I see it's pretty tough because its acceptance rate it's only 47.9%, so usually it's a tough problem. Okay. Yeah, let's continue. So while left is not equal to right, we do a sum. So let sum would be back of left, right, iterator sum. So this in itself would be a big O of n. So that would be a sum as I32. So we have this sum. So we do the check. If sum it's 0, then we'll have a solution and we will erase from our vector. Maybe in this case, should I pass it as a mutable reference? I don't know. Okay, so if this is 0, then we've got a sequence here. Else, if it's not 0, because this is important, if it's not 0, we do right minus equal 1. But we do right minus equal 1 if right plus 1 it's greater than left, because we don't want to sum right. Else we don't care for now for else. Okay, so this okay, so let me do let immutable result would be a back, and here we'll do like result will equal yeah, everything besides left and right. How can I do that? Oh my god. So much work for this problem. To clean it up. I guess have my back. I'll do it as an iterator. I'll do a skip. How many? Skip left. I'll do actually not skip left, but skip or take. Yeah, take. Take left. Skip. How many? Next. It will be like right minus left. Yeah, something like that. And then we'll collect. We'll collect. So that would give us my result. Okay, so it's I'll need to dereference them to not have troubles. Yeah, but we're not moving the left pointer at all. So when do we move it? So I guess here we should move it. Else we do like left plus equal 1 and right will be back len minus 1. So will this insanity work? No, it will not. We'll need to check why. Okay, so let me collapse this. Okay. Yeah, I'm not sure about new people who will join the stream and see the code, but I got annoyed. I really want to see a fast solution. Okay, so what's the sum? It's 4. So 0 and 4. Okay. So it's not this. Then we move right. If right plus... Wait, what's this insanity? What does this stuff even mean? Right plus 1. No, this is completely useless. I think I wanted to tell here. Wait, if right is greater than left plus 1. Okay, that makes more sense. So yeah, anyway, we reduce right. Again, we reduce right. Sum is 0. We've got result, it's empty. So it looks like this stuff didn't work at all. So take left. Left is 0. Yeah, I'll need to work a bit on how to remove a sequence from a vector. remainder. I think like is there a way on how I can collect what's remaining? Okay, so let me go here again. So I have 2 pointers, like left, let's say 0, and right being right being 5. So, and I have a couple of numbers, 7, 8, 9. So if I go with this iterator approach, what does it mean to take? No, I don't need to take, I need to skip. And I need to skip starting as okay, so maybe I can use a partition by. Partition by. Wait, why I'm complicating it so much? I think like simplest way is to use like an index and a filter. So yeah, that would be the easiest way. Yeah, looks like I'm a bit exhausted, so that's why I do not think straight. So we do have this part, then we'll need to enumerate. That's the trick. Then we'll do a filter where we'll have like index and we don't care about the value. And now we'll need to check if index it's inside the range. Maybe I can do it like this, left, right, and then contains index. I guess I don't need the if part. I just I'll do this trick. Okay, so we have this. Then we'll do a map. I will not need anymore the index, so I don't care about this. I'll need the x part, and I'll need to dereference x, and I'll collect. And that should be it. So now I should be a bit more straightforward, I guess. So let me debug it again. Start again. It looks like I messed up something. Okay, so we have the sum part. Let me move this below, which I don't need. So sum would be 4. That's fine. Let's go here again. So sum it's 3. Let's go again. Sum is 0. Okay, so let's see what's the result in our case. It's 1, 2, minus 3. Oh, I need to select everything which is not contained. So I need a reversed one. I feel like I have troubles to exit this loop. So yeah, I have my result 3-1. Now the trick is I have my result, though in this case I will need to clean up it recursively. But how can I exit my this infinite loop? What would be okay, so sum is 0. Yeah, okay, so we clean it up. I guess I break here. That's the trick, I don't know. Yeah, let's try it. Let's try it. So yeah, that's not right. I mean, it's fine. It's okay. So now this works. Now this works. So are we done? What? Did we finish? I mean, why? What? If we finish, then that would be pretty cool. I hope this will be accepted, because I do not ever want to get back to this problem ever again. Too much work for a simple problem. Imagine you got it during an interview. I don't know. I mean, I have like 2 hours spent on it. Most likely you will fail. I mean, like, if you got it during an interview, you're done. Okay, so we have a wrong answer. Yeah, that's the next stage, the recursion part. That's the next recursion part. And I was sure that I'll have a scenario like this. I mean, how it's possible to not have a scenario like this? Because we'll need to go recursively and remove again. But my trouble is I do not see when to finish this. When this is finished, when this for loop. Because I got to the first stage, I removed the first one. But now if you can check, we can remove another stage like this one. This is also removable. And the end result should be 151. Okay, so we've got, let me get here. So we've got to this stage. Yeah, let me collapse this. Let me collapse this one. We've got this here. Here, unfortunately, we cannot just break. Here, we'll need to go recursively, like return solution of clean up zero sum and pass the result. Though this will work, the trouble is how do I exit? I guess it will cycle around somewhere here. So we'll not have a zero sum ever. We'll not have a zero sum. Okay, so that makes sense. Okay, so let me check here. This else branch. So we do this, we go left. And if left is greater than right, then while loop exits. You know, this has potential to work right away. 3, 1. Wait a second. Why it did go with empty results? Something it's not right. Okay. So we've got here, we've got here, we've got here. Result, free one. Okay, so we go again. Oh, so result will not be empty array. Result would be vac. I guess clone. Yeah, maybe like this. Run test. So the third one, it's 5 minus 2 minus 5. Wait, I've got 151. Wait, oh, it's correct. It's correct. It's 151. My test case was not right. Oh my god! So this works. Finally, finally. Who made this problem? Wish you a lot of help, bro. Very entertaining. I don't even care what will be the complexity. I just want to finish it and go to sleep. Okay. So 95 lines of code, out of which, yeah, this one with the recursive approach of what did I do? Okay, let's submit and hope this will be accepted. Please, runtime error. Wait, -1 and 1, and I have troubles with -1 and 1. Okay, so I assume yeah, I guess with -1 and 1, I will have troubles with this subtract with overflow. Okay. Because there is nothing there. I guess, yeah. Vac is empty. Return. Come back. Wherever. Okay, so now it works. Yeah, let me type it there. Use test case, submit. Oh, wait, that's what's that? Ah, it's 0. Oh my god. Yeah. Yeah, this test case is funny. And literally, what can I do here? So it's 0. I guess I can just remove zeros right away. Oh my god, that's so... boring. Okay. Some filter, I guess, filter. Okay, so right, and I guess I can put here index to be right and the number, it should not be 0. Yes, like that. Right, left. Wait, I've cleaned them up. So how it's possible? This should not contain this, and oh wait, yeah. Let me write another filter. I think it will be cleaner this way. So map filter x not equal 0. So I shouldn't have zeros in my result. How it's possible? Run test. How is it possible? How is it possible? Yeah, let me use the debugger. I don't understand. Okay, so not empty, 0, 1. I guess 0, 0. Oh, and we don't enter inside. So it's only 1. Po, po, po. That's very sad way to write code. But if I put here less or equal, then things will go south. Oh no, it does work. Okay, that solved my trouble. So let's run again. Okay, some success. So we have 0, 2 and output is 0, 2. But looks like we are closer. We are getting closer to all tests passing. So hopefully this nightmare will end pretty soon. Okay, let's go with the debugger. So what's going on here? We clone it. We do the sum. It's not that. Wait a second. I feel like I missed something here. Some sign issues. So we have left 0, right 1. If right is greater than left plus 1, I mean, that's freaking annoying. I'll do it like this, I guess. Yeah, it will want an into iterator. Okay, so into too many. This it's clear. This is clear. This we will remove. Or should we? Maybe I should clean them up at this stage. Yeah, that would be even cleaner. Yeah, I probably should just clean up zeros from the sequence because they are zeros and they will go out in either case. So not even here will I leave the logic. So I will keep it at this stage. So that's okay. Here let back. Here back. Iterator filter x not equal to 0 and collect. Okay, so I'm filtering them at this stage. This I feel like it can be consumed. Maybe a result like this. Yeah, we'll need to dereference this. Here plus this. And this needs to be immutable stuff. And here it will be a result, and here result. And there is a problem. What's okay? Because you're giving an explicit type. That's fine. So it will be a vec of I32. So how about now? What? 122 line. Oh, so my test cases are not right. Run test. Okay, range and index 2 out of range for slice of length 1. Okay, so we've gotten out of range. I guess it's the first one. So let's start the debugger. So result is 2 at this moment. I guess if it's a 1 value and it's not 0, then maybe I can do it like this. If vec is empty or vec len it's 1. Then return result. I guess here it will be result in this case. If it's greater, then we start our logic, because it doesn't make any sense to continue without it. Okay, so all tests are working fine. So let's copy this one and replace again on LeetCode and hope, pray that this would be accepted. Yeah, this changed as well, indeed. Okay, so let's submit. Please, LeetCodians, accept my problem. Yeah, this one failed. That's interesting. This one failed, and it was working before. So I assume this would be an empty vector. But something is not right. Okay, so let's debug. Wait, something is not right. Yeah, let's try again. So, to collapse this too. Okay, so yeah, that's right. And then I do this. And for the looks like I have troubles with so it's 2. Wait. It's not back, it's result. That's weird. Okay. Okay, so we have this. Some. How did we get already there? So yeah, it was a mistake in the code, a small bug. So here should be result. Let's run again. And let's submit. Uh, 0, 3, -1. Yeah, I will not. Until I finish this problem, I will not go to sleep. So, 0, 3, -1. And the expected result, I assume, would be like 3 and -1. So, okay. Left is 1, right is 1. Wait a minute. No. They cannot be equal. They should not be equal. Okay, which one is failing right now? It's yes, first one is failing. Okay. So this, okay, we do this. So left is 1, right is how? That's the trouble. Yeah, I've renamed this and forgot to update it everywhere. Okay, let's arrange it a bit. Wherever. Rust doesn't want it to be arranged. So yeah, let's paste this one back. And now use this case and let's run again. Let's submit it. Oh my freaking god. Not even 2 hours passed to finish this one. But it's very pleasant when you get it done. Yeah, and now there is a moment. So that would be the logic to remove them. So this is the trick I didn't know. I mean, mine it's I guess pretty straightforward approach. A little bit ugly, but it's working. Okay, guys, I think I'm done for the day. I'm exhausted. I had bigger plans, but what can we do? I mean, some problems we solve in 5 minutes, others in 2 hours. So that's experience. Yeah, bye bye. Probably on Friday or during the weekend will be the next stream. So wish everyone a nice evening and happy lead coding.